So you probably know what a prime number is. A number that factors are 1 in itself. So for example, 15 is equal to 3 times 5. That has factors 3 and 5, so it's not prime. But 11, say, can't be written as a product of any other prime numbers apart from 1 in itself. So 11 we say is prime. If I list all the prime numbers, we know that 1 isn't here. That's just a convention, there's no real reason for that. But if I make a list of the first few prime numbers here, it's a natural question to ask whether this list goes on forever, i.e. is there some largest prime number, p, such that I could make a whole list of all the prime numbers and I would end up at p and that would be it. Well, to consider whether there is or not, and my title here suggests that the answer is going to be that there is no such largest prime, you can always find a bigger one. Suppose we have got this list and there is a largest prime number, then I can write this number 2 times 3 times 5 times 7 times 11 times 13 times 17 all the way up to p. Let's just call that number capital N. So I've multiplied together all of the prime numbers. Now, let's think about the number n plus 1, and I want to ask the question, is, say, 7 a factor of n plus 1? Well, the first thing I'm going to notice here is that 7 is a factor of n. We can see that because n is 7 times all of these other numbers. So 7 is a factor of n. So n is a multiple of 7, and then the next multiple of 7 comes at n plus 7. So n plus 1 is somewhere in here, and therefore n plus 1 isn't a multiple of 7. So the answer to this question is no. Now, 7 wasn't particularly unique here. I could have picked any of the prime numbers here. I could have picked, say, 13 instead and asked the same question, is 13 a factor of n plus 1? And in exactly the same way I could say that 13 is a factor of n because it appears in this decomposition, and so the next multiple of 13 is n plus 13 and n plus 1 is somewhere in here. So n plus 1 doesn't have 13 as a factor either. And by exactly the same argument then, we can say that actually none of these numbers are factors of n plus 1 either. And since this now is all of the prime numbers, supposing that p is the biggest prime number, we then know that n plus 1 can have no prime factors. So what sort of number is n plus 1? Well, n plus 1 is a number a bit like this one up here, a bit like 11. The only way that I could write it as something times something else is by writing it as itself times 1. Here is n plus 1 times 1. It's not like 15, which is a composite number. So n plus 1 then must itself be a prime number. But that's a bit contradictory because I've said that p is the largest prime number. So the idea that there is a prime number n plus 1 that's bigger than p is a bit of a contradiction. Essentially what we've said is if you sort of find any prime number p, I can construct another number that's bigger than it, n plus 1 here as we've done, and that number must also be prime. So for any sort of candidate for the largest prime number p, we can always find a bigger one. Hence, there can be no largest prime, and so there are infinitely many prime numbers.